So I'm going to consider, as I discussed in the first session and the second session about the matrix game. So I'm going to consider that game once again. So let us consider the game. Let us consider the game. Uh, Capital A is equal to 3, -1, and 9, and we have seen that the maximum value of the game is -1, maximum value of the game is -1, and minimax value of the game is minimax value of the game is 3, and value of the game does not exist. Value of the game does not exist does not exist if we stick to if we stick to pure strategies. If we stick to pure strategies, so we shall try to analyze the situation. We shall try to analyze the situation from mixed strategy point of view. From mixed strategic point of view. From mixed strategic point of view. So to write this solution, you must write that let us consider probabilities. Let us consider probabilities x and 1 minus x for player 1 or row player. I am considering the probabilities x and 1 minus x because you see the total probability in this case will be 0, because x plus 1 minus x is 1. So not 0, 1, because whatever probability you select, the total probability must be equal to 1. And let us consider probabilities. Let us consider probabilities y1 minus y for player 2, that is called the column player. Now probably you have heard about this word which is called expectation. Probably you have heard about this word because you are actually attending the class of probability theory in statistics, and probably ma'am has told you about the expectation, the term called expectation. And when we talk about when there is a random variable, there is a random variable capital X taking values x1, x2, xn with probabilities with probabilities with probabilities p1, p2, pn, then expectation of capital X, E of capital X, is actually defined as p1 x1, p2 x2, pn xn. Today's discussion will take, this discussion, I may not finish this discussion in today's class because it actually is very difficult to get into the actual point. So gradually slowly I am moving. So next week, next Saturday, after giving the examination, when we shall continue, maybe at that point of time, I can reach to the ultimate part which I need to discuss with you, because it takes lots of discussions, because this portion is very difficult to understand. Many more things from the theory of probability is required, so you have to have some kind of patience. Okay, so expectation is defined, you see, when there is a random variable capital X taking values x1, x2, xn with probabilities p1, p2, pn, then E of x is equal to p1 x1 p2x plus p2 x2 plus pn xn. So we are going to write the matrix. First of all, I'm going to use this particular formula to the given matrix in the next page, and then I'm going to talk about a little bit about expectation. Okay, because you have to understand what expectation is. So first of all, why did I write this definition of expectation over here? First of all, let us use to our game matrix. So to identify whether this game has value from pure strategic point of view, that is our step one. To solve this problem, we have actually used step one, and that is the step one. Now this analysis is our step two. This analysis is our step two. In step two, we are analyzing when we have seen that value of the game does not exist. That is our step two. Okay, if you're writing in your copy, then keep one or two blank pages. If the class ends, you keep one or two blank pages, because I may discuss further in the next class, and then you are going to fill it up. Okay, so this is your step two, and in step two, I'm going to apply to the given matrix. So I'm writing the matrix once again. So my matrix is -1 and 3 -1 and -1 9. 3 -1 -1. I have to write it in middle. Just a minute. 3 -1 -1 and 9. Okay, and that is I'm putting here capital B, the player capital B and capital A, as usually we do. And according to our choice, I'm putting X over here and 1 minus X over there. Now, Shumona can say that, yes, sir, why did you put X minus X over here and 1 minus X over there? Now, I must say that you can interchange the position. You can consider X in that part and 1 minus X in that part. There is no restriction, but total probability must be equal to 1. And you are going to put Y over there and 1 minus Y over there. So these are the probabilities. These are the probabilities we are actually considering, with which player B and player A are going to select their rows and columns respectively, so that Y plus 1 minus Y total probability is equal to 1, and X plus 1 minus X, that is equal to 1. Okay, now what will be the expectation? What will be the expectation in this particular case? What will be the expectation in this particular case? So if I call this pair, capital X, I call this pair X and 1 minus X as capital X. Okay, if I call this pair capital X, if I call this pair X 1 minus X as capital X, then expectation of capital X, and by keeping 1, this notation I am using, this one is actually column 1. This one is actually column 1, and I'm keeping column 1 fixed. I'm keeping column 1 fixed. The expectation of capital X will be, according to our definition, that would be 3 into X plus minus 1 into 1 minus X. Why is it so? Just look at this. We multiply the value with the probability. We multiply the value with the probability. A particular value is multiplied by the probability. So here the value is this 3, and its corresponding probability is X. So it is, you can consider this to be your X1 and that to be your P1. And you can consider this to be your X2 and that to be your P2, if you want to correlate the two things. And similarly, E of X, when the column 2 is fixed, okay, then in that case you are going to write -1 into X plus 1 minus X into 9. And if you calculate this, what will I get? 3X plus X minus 1, which is 4X minus 1. And if I get this -1 into X, that is minus X minus 9X plus 9, that becomes your 9 minus 10x. 9 minus 10x. So these two values we have calculated. These are called the expectations. These are called the expectations for the player A. These are called the expectations for the player A. Player A. And similarly for player B, we can calculate the expectations in the following manner. I'm going to write it on this side. So expectation for player B. So player B, the expectation will be, I am keeping first row fixed and calculating the expectation y. Y is my vector y minus y comma 1 minus y. This is my vector. So here I am putting row 1 fixed, row 1 fixed. You don't have to write these fixed in at the time of examination. I'm to make you understand, I'm writing it actually. So this becomes what? Let us calculate. So we consider the value which is 3 and its probability now is y, and that becomes minus 1. This is the value and its probability is 1 minus y. And if I calculate this, we get 3y plus y, that is 4y, and that is minus 1, 4y minus 1. And player B expectation of y when row 2 is fixed, when row 2 is fixed, then it becomes then it becomes just a minute. Okay, then it becomes minus 1 into y, minus 1 into y plus 9 into 1 minus y, 9 into 1 minus y, and that becomes minus 1 into y minus 9y, that is minus 10y, so 9 minus 10y. So 4 expectations we have actually calculated. 4 expectations we have actually calculated. So if you are writing these calculations in your copy, quickly copy this particular the whatever is written in front of you is quickly copy it, because so that I can go to the next page and I can discuss a few things about expectations. Once you are done, you can write in the chat box that I am done. One student done means I shall consider that the entire class probably has finished writing. Because before I proceed something, then you have to understand what expectation is, because this concept of expectation is not clear to you. Because whenever I write x1 into p1 and x2 into p2, probably you are thinking, why should I multiply a particular value by its corresponding probability? What is the point in that? So you have to understand that. Okay.
Sir, one question.
Yes, sure.
Sir, in CA2 syllabus, apart from assignment problem, what are the topics you told us to prepare? Can you once more repeat?
In my part, or only assignment problems, entire unit 3 will be there. And for madam's portion, the probability
Okay,
part,
sir.
that is unit 2, will be there in its entirety, entire unit 3 and entire unit 2.
Entire unit 2. Okay.
Unit 2 of
Thank.
statistics and unit 3 of OR.
Okay, sir.
Okay. Now
স্যার এক্সামটা কি স্যাটারডে আপনি যে টাইমে ক্লাস নেন ওই টাইমে হবে?
today my class was at actually at 3:20 p.m. Now Arnab sir has changed the routine and said that for today on I had to take the class at 5:30. Now if you want, then I can take the exam take the exam at 5:30 and then I can continue with the class. If you want, then I can, whatever. I don't know what will happen at that point of time. I think Saturday will be a kind of busy day for me, so it would be nice if I take the examination in the evening. That means at 5:30, and I shall ask Arnab sir that I shall Even I shall take the classes 5:30, and then I'm going to take the exam. After the exam, I shall continue with the discussion. The time has not yet been decided, but on Saturday I'm going to take it.
Sir, it will be of 25 marks MCQ, so it will be of 25 MCQs, sir.
No, no,
Okay, okay.
no. The marks will be uneven. Marks of the questions
Okay,
will be uneven. Some questions may have 3 marks, some questions may have 2 marks,
okay,
some 1.
okay, sir.
Okay, so
I understand.
this is not an issue. That is not the case, that all the questions will be depending upon the structure of the question. The question will, I shall put the marks max to max 3, not more than that.
Okay. Sir, for that we have to solve the problem and send it to you, or for only MCQ we have to do, sir?
For this, you have to sit with your copy, pen and paper. You have to solve the question. You have to solve the question, and then you are going to attempt it. I don't have to send me the solution. No,
Okay, sir.
just attempt the Google form.
Okay, sir.
But
And sir, time control, sir, time, how much time will you get?
for 25, if there is a 30 marks internal test, we actually give 1 hour. So for 25 marks question, we are also going to give 1 hour. 1 hour.
Okay, sir.
Okay, so that's the thing. Any more question regarding that? So if you have finished copying, writing this page which is in front of you, you can just write in chat box so that I can move on. Can I go to the next page? Yeah, okay. Now let me talk about, and remember, if I'm unable to finish this problem in today's class, that is up to this. The problem is this particular page. This page, whatever I've written over here, and that page, these two pages are part of the solution. Part of the solution of the given problem. So here I'm writing actually part of the solution. Part of the solution. And here I'm going to write part of the solution. Part of the solution. So that you can understand. Now I'm going to discuss something which is not a part of the solution. Not a part of the solution. Okay, so let me talk about expectation. What is expectation actually? Probably you think that expectation is a very new term, but it is not actually. It is not. Now to understand expectation, let me talk about a few things about frequency distribution. You very well know what frequency distribution is. So as you have done a statistics class, and you know that we consider the values small x and their frequencies fx, and you say that these are the values x1 x2 dot 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 xn, and these are the frequencies f1 f2 dot 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 fn. Then if it is so, then what will be the formula for arithmetic mean? Can you tell me? Can you write in short, or can you unmute yourself and tell me what will be the formula for arithmetic mean?
Summation summation xi fi
Okay.
by fi. Summation fi, sorry.
Summation fi. So what we do, okay, mute yourself. What we do, we actually multiply the value with the frequency x1 f1, then we multiply x2 f2, then we multiply xn fn. Okay, and then we divide the entire thing by f1 plus f2 plus dot 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 fn, and we say that this is our arithmetic mean. This is our arithmetic mean. Now what will happen? What will happen if we replace all the frequencies by probabilities? So I'm considering the same chart, x fx, no, not fx. I'm writing in place of fx, I'm writing x px, and I'm saying that x1 x2 dot 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 xn, and p1 p2 dot 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 pn, and this arithmetic mean will be this arithmetic mean will be, what will be the formula? It will be similar to that, only the fi's will be replaced by pi's. So we can write it as x1 p1 plus x2 p2 plus dot 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 plus xn pn, and the entire thing will be divided by p1 plus p2 plus dot 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 plus pn. Now you see, since if you say to me that your chart of probability is a complete chart, by complete chart we mean that you have considered all the values and you have considered all the probabilities, all the possible probabilities. Say for example, if you are tossing a coin and you say you are tossing a coin, and you are, if I ask you what are the outcomes, and you say the outcome is h, and if I ask you what is the probability, probably you are saying that h equals, the probability of h is half, then your chart is not complete because your total probability is not 1. Now if I ask you that is there anything missing, oh you say, oh sir, yeah, it is, one thing is missing, that is t is missing, and for t the probability is half, then I can say that your chart is complete because the total probability comes out to be 1. So that's why I am saying that if you consider that your chart to be considered, if you say that your chart is complete chart, that in with respect to that I can write that p1 plus p2 plus dot 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 plus pn, this total probability will be equal to 1. This total probability will be equal to 1. And if this total probability is 1, that this denominator portion will become 1, and we will get a formula x1 p1 plus x2 p2 plus dot 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 plus xn pn, and this formula is called expectation of the random variable x. Random variable x. So if you ask me, sir, is expectation is a kind of arithmetic mean? Yeah, it is the mean of the random variable, mean of the random variable capital X. It is the mean of the random variable capital X, and in your case, the random variable capital X, the random variable capital X is actually the payoffs present in the matrix, present in the matrix, in the game matrix, in the game matrix. So these are the payoffs present in the game matrix. Okay. Now probably you have understood that expectation is nothing new. It is related to kind of arithmetic mean related to probability distribution. Is a mean of a random variable capital X. In your case, your random variables are the values which are being taken, which take the values. These are called payoff. This is a payoff. This is a payoff. These are called payoffs. This is a payoff. This is a payoff. So for all these payoffs, you have calculated your expectations. Okay. Now I am going to apply one theorem over here, and that theorem I'm going to write the theorem, but the theorem is actually very difficult to write because it has too many technicalities and mathematical expressions. I'm talking about theorem 1.3.7 of the book. So in brief, I can write it as, you see, the theorem says, in the next class I shall discuss about the theorem, the statement of the theorem. If you want, I shall write it, and I can make you understand about the terms present in the theorem. But briefly, if I want to complete my today's problem, and since I have started the problem, so it would be not nice if I do not complete it. So part of the problem, again I am going back to the problem. Okay, so after this step, I mean the step 2, it is actually our step 2. I am going to write step 3, and step 3 I'm actually using that theorem which is there in the book. It is saying that if V is the value of the game, then V is the value of the game, then the theorem says that that value should be less than or equal to, that value should be less than or equal to ex1 as well as ex2. This value must be less than or equal to ex1 and must also be less than or equal to ex2. And this value must be greater than or equal to e1y and must be greater than or equal to e2y. How do I write it? Actually, I'm using a theorem. Theorem number 1.3.7 of E.N. Baron book. Okay. Now you see that since equality symbol is there, so without any loss of generality, we can consider V to be equal to E of x1 and it is to be equal to E of x2. And similarly, V can be equated to E of 1y should be equal to E of 2y. Now you can put the values over there. What are the values which I calculated? 4x minus 1 and 9 minus 10x. 4x minus 1 and 9 minus 10x. And here you can put the values. 4y minus 1, 9 minus 10y. 4y minus 1, 9 minus 10y. So if I solve it, what will I get? We get 14x is equal to 10 and x equal to 10 by 14 or 5 by 7. And if I do it over here, we will get 10y is equal to, 14y is equal to 10, which is y equal to 10 by 14, which is 5 by 7. What was your vector? Your first vector, I mean the mixed strategy, your first mixed strategy for player A was x comma 1 minus x, and therefore that is equal to 5 by 7, 1 minus 5 by 7, that is 2 by 7. That is your mixed strategy. And your second vector was corresponding to the mixed strategy y comma 1 minus y, that is 5 by 7 and 2 by 7. So both the players are having a kind of mixed strategy, which is 5 by 7 and 2 by 7, 5 by 7 and 2 by 7. If you ask me what will be the value of the game, now that part, if I ask me what is the value of the game in this case, value of the game, and that is the step 4 of the problem. This part I am going to discuss in the next class, not today, because time will not permit me to do so. And if you ask me that, please sir, try to elaborate this thing, 5 by 7 and 2 by 7, what do we mean by that? That means that this 2 by 2 matrix game is played 7 times. 5 times will happen that player A is going to select his strategy 1 and 2 times he is going to select his strategy 2. And similar is the case with player B. 5 times is he going to select the strategy 1 and 2 times he is going to select the strategy 2. So that is the meaning of what I have got from our respective calculation. So you see, if a game, the main important part is that if a matrix game is given to you, a matrix game, your first job is to check whether the value of the game is existing or not from pure strategic point of view. And if it exists, then you have to stop. No need to proceed with step 2 and 3 and 4. But if the value of the game doesn't exist from pure strategic point of view, then you have to proceed accordingly with step 2, 3 and 4. And at least I can say that we have found the mixed strategies, but yet we do not know what will be the value of the game, which will be discussed in the next class. So I have saved your chat, and this much I am going to discuss in today's class. If you have asked any
স্যার
question,
কোয়েশ্চেন আছে
yes, bolo.
হ্যাঁ বলছি আপনি এখানে বললেন না যে 5/7 ফর 1 and 2/7 ফর 2 প্রবাবিলিটি হ্যাঁ তাহলে এটা কেন ম্যাট্রিক্সটার এগেইনস্টে হচ্ছে না মানে ম্যাট্রিক্সটা আমাদের যেরকম আছে 3 -1 আর -1 আর 9 তাহলে আমরা এটা কেন ধরছি না যে x এর ভ্যালুটা হচ্ছে 5/7 তার মানে আমরা 3টা মানে যদি 7 বার খেলা হয় আমরা 5 বার 3টা অ্যাসাইন করছি আপনি যেভাবে বোঝালেন এটা কেন ধরছি না
তোমার কোয়েশ্চেনটা আমার কাছে ক্লিয়ার হয়নি, তুমি আমাকে ক্লাসের পরে ফোন করবে, আমি বলে দেবো। আদারওয়াইজ এটা যদি সবার কোয়েশ্চেন হয় আমি ক্লাসের নেক্সট দিন ক্লাসে আবার ডিসকাস করে দেবো, কারণ এখন ক্লাস
নেক্সট দিন ক্লাসে ডিসকাস করবেন।
আচ্ছা ঠিক আছে, ওকে, আবার কোয়েশ্চেনটা তুমি আমায় করবে, আবার বলে দেবো আমি।
হ্যাঁ স্যার ঠিক আছে।
ওকে ওকে ঠিক আছে, ওকে। সো দিস মাচ ফর টুডে, সি ইউ নেক্সট উইক, and exam date will be, yeah, okay, okay.